Okay, so today we're going to be making our solar irradiance sensors. And what these sensors are going to be used for is to measure the amount of sunlight on our systems. So we're going to have a control group and a test group, or the independent variable. So in our control group, we're going to have a garden bed with no solar panels, and we're going to use our solar irradiance sensor to measure the amount of sunlight shining onto that garden bed. In our independent variable, we're going to have another garden bed, but this one's going to be constructed with a solar module over top of it. And what we're going to do is put the solar irradiance sensor underneath that bed, and we're going to be able to measure the amount of sunlight that is still getting past our solar panels, or the diffuse light coming from the edges that will then get onto our solar irradiance sensor. So then we can see how much sunlight the plants are getting in both our control system and our independent variable. So we're going to go over the contents of what each bag should have, and these should be the bags that start out labeled by solar cells. So the first thing we should have are 2 solar cells, which will look like this. I just have one here for right now, but we're going to have 2 of these. And you can see they're just a little solar cell. If you have a little bit of foil or plastic wrap on top of yours to protect it, that's perfectly fine. I personally would leave it on right now, and we can take it off later. And then you'll see on the back, we'll be soldering to the back, and we'll go over that later. We should have 2 RCA plugs, or RCA males. And you should have 1 red one and 1 black one. And these might look familiar because they're the old style plugs that we used to use for TVs. And they will twist off, and you can see where we'll be soldering to. So for the purpose of this video, mine's going to be a little beat up because I had to recycle some old used ones, but nonetheless you should still be able to use the same concepts. And you'll have 1 red one, 1 black one, and that's just to help distinguish between the 2 different sensors that you're creating. You should also have 2 10 ohm resistors. This is the ohm sign, and we should have 2 of these. For right now, I just have 1, but we'll have 2 of these, and I'll explain later in this video how these work. We should also have 2 pieces of heat shrink. This is a little black tube. And what this will be used for is to help protect the wires from any environmental conditions or water or moisture getting inside, so they don't corrode the wires. And then finally, you should have 2 long white cords. These should be about 10 feet long. Each one will have a red and black wire inside that should be pre-stripped for you. So we should need 2 of these. So for the purposes right now, I'm going to go ahead and just build 1 of these. And you can go ahead and pause the video as we're going so you can follow along at your own pace. First thing we're going to do is make sure our soldering iron's heated up, the tip is cleaned off. I'll be using a little of the steel wool that you don't have, but you can also just use your sponge, a little bit of moisture on there, clean off the tips a little bit, make sure it's nice and hot, and also make sure you have your smoke ventilator set up. And we want a nice clean working surface to make sure we don't burn anything or ourselves. And so I'm going to have my helping hand set up. So the first thing we're going to do is we're going to start out with our wire. We're going to grab 1 piece of wire. And what I like to do is just twist the ends of the red and black wire to get them nice and tight, easier to work with. And we're going to also take one of our RCA plugs. Doesn't matter which color you decide to use. And we're going to unscrew the back off. And the first thing we do before we get started is we're going to go ahead and just slide this on with the small end going in first. And this way, once we solder our connections, we can easily pull this up and screw it into our plug. And you'll see how this will come along later for a nice clean finish. The next thing we're going to do is we're going to slide on our heat shrink. I almost always forget to put this on once I solder, it's too late. So let's just go ahead and slide this on now so we don't forget. And then from there, we are ready to solder. So let's go ahead and look at our RCA plug. Now, like I said, mine's a little beat up, but you should have two prongs. One that looks kind of like a little tail. Yours should look a lot nicer than mine does right now. And then the other one, which will be a smaller prong on the top. And mine's cut off, but there's a little tiny hole in there. And what we're gonna do is solder both of our connections to this. Our black connection, or the ground negative, is gonna go to where the tail is. And the red connection is gonna go to your upper prong on the top. We're gonna do one at a time, and the really important thing is to make sure that these don't touch each other even after they're soldered. So I use my helping hands. I'm gonna get this set up, and we're gonna go ahead and start with our black one first. And what I like to do is just put a little bit of, figure out exactly how much wire we need. So we're gonna have a little bit of excess. See how this goes a little bit further? So what I'd like to do is take your little wire snippers and cut off some of that excess. And this will help us make sure we don't short our circuit later. And clean that up a little bit. And then put this in my helping hands. Put this right here. And what I like to also do is kind of close off these tails a little bit, which will be easier when yours aren't beat up like mine, to kind of grip this into place. Let me go ahead and close mine up a little bit first. Now you can see I have it kind of gripped in there, holding it in place. Not super well, but enough to where I can solder to it. And I'm going to take my solder and my soldering iron. And I'm just going to apply a little bit of solder right into here to get this nice and electrically sound. And also to make it mechanically in place so that way this doesn't slide once we have our finished sensor. So now that it is soldered, wait for it to cool down a little bit, and we should be able to do just kind of like a little pull test just to make sure it's in place. You don't want to yank on it too hard and pull it out, but see how I'm pulling on it, and we know it's nice and snug. So what I like to do from here is I want to go ahead and cut some of this excess tail off, because we don't want this to get in the way and touch our positive wire. Make sure you have your safety glasses on. Before you do that, make sure that the piece that's coming off doesn't hit you in the eyes. And you see we have a nice clean connection right there. Now what we can do to test this too is you can use your multimeter. And you can use a multimeter to test something called continuity. And if you see on my multimeter, which will look a little different than yours, I have one symbol right here. It looks like a triangle and a straight line. That's a diode symbol, or the sound signal. And this will basically help me test my circuit and make sure it's a closed circuit. So I have it set on that setting. And I'm going to grab the other end of the wire that we're not soldering to at the moment. And we know we just soldered our black wire. So if I put one probe on my black wire and one probe on the outer shell, the circle part of this RCA cable, we get a sound. That lets us know that we have continuity. Our signal's flowing from this probe all the way to this probe. So now if I touch the pointing looking object, the cylinder object in the middle, the pen, notice how there's no sound. And that's because there's not continuity, because that signal's going from here to here, and then there's nowhere else for it to flow. So that's a good sign. We know our first wire is complete. Now we're going to work on our red wire. And we're going to want to do the same thing. We're going to want to cut some of this excess off, and we're going to want to be able to put a nice clean connection right there on the top. So I'm going to go ahead and cut some of this red first. Notice how I don't need very much to solder to it at all. So use my helping hands once again. And this will take a little bit of time to get you into a place that you're comfortable with, where it kind of stays intact. And for me, I think that's going to be good for right now. And we're going to push this into place and then add a little bit of solder right here. Now, notice how it's still popping up. So what I'm going to use is use my little cutters. I'm going to use that to hold it in place while it cools down and dries. And once again, I'm going to do just a little pull test on there. We have a nice connection. I can see that my red and my black's not touching each other. So that's a good sign. And I'm going to go ahead and do one more continuity test. Now with my red wire. Bring my multimeter back over. So if I touch to my red wire at the end, because that's the one we're testing now, to this prong, we have continuity, and that's a good sign. If I just want to check right here too, see, we're both good. Now if I touch it to the shell, no continuity. That's a good sign because that's for our black wire. So we are ready to move on to the next part, which will be covering this all up and making it look a lot nicer. So notice how I have a little kink in my black wire and my red wire straight. That's because one wire was a little bit shorter than the other. If you can, make your wires the same length and not have that issue, that would be great, but it'll still work just like this. So what we're going to do is we're going to slide our heat shrink up. And the important part from this phase is once you slide this in, your wires are going to push together a little bit more. You want to make sure that they're not going to connect at all. And make sure that you have really nice clean connections right here. You cut off as much excess as you can. That way when they get pushed in together, they don't have any connections. You're going to slide that up to the end. Now typically with heat shrink, you would have a lighter or a heat gun and this will shrink down. But for us, we're just going to use our soldering iron. And what you want to do is just touch the edges of it and just kind of move it back and forth, apply that heat, but we're not holding it in one place too long because we don't want to, melt our heat shrink at all. And starting out at the top near where the sensor is, what it's going to do is just shrink everything down, cover our wires, and so that we don't have any spots for moisture to get in. And I'm going to make a nice clean shrinkage right around the insulation of the white wire. Give us a clean finish. Careful with your fingers, make sure you don't burn anything right here. And we are complete. So this will be a little warm at the beginning, so give it a little bit of time to cool down. And then what we're going to do now is slide up the bottom part of our wire, or our RCA connection. And you don't want to force it too much, but you see this part right here is going to struggle getting on top of your heat shrink a little bit. So one thing you can do is slide it back down and shrink this down a little bit more, if that's the case. You want to slide it up and then screw that on into place. And we have our finished wire. Now you can see we have our heat shrink still showing, which is fine. But now this is going to be relatively protected from any kind of moisture when it's in our system, so that way we don't get any corrosion inside here. So now this will be what plugs into our microcontroller on our printed circuit boards. And that'll be how we carry the signal from this end to our actual brains of our device in the microcontroller. So we're going to move on to soldering our solar cell next. So what we're going to want to do here is we're going to want to take our solar cell. If you notice, solar cell has a positive and negative that come out, and they give us spots where this is where the wire is going in from the solar cell, which you can see right up here. And they give us spots where we can solder onto them, where they have their solder points right here. And they give us 2 other pads for each positive and 2 other pads for the negative. So we're going to go ahead and we're going to use these bottom 2 pads to solder our wires to. We're going to connect the red wire here and the black wire here. So What we're gonna do is go ahead and twist these wire ends up a little bit, make them a little bit easier to work with. And we're gonna use our helping hands, and let's go ahead and start with the positive wire first. You want to be careful when you're using your helping hands on this that you're not scratching up the front of your solar cell. So you don't want to slide it when it's inside these hands. You just want to very gently use the little alligator clips on here to put it in place and not scrape your solar cell. So I have my positive wire, the red wire, right on top of the positive pad that they give me. I know it's positive because there's positive on this side. So this pad and this pad are both positive. I want to take our soldering iron and our solder and just apply a nice little dab of solder onto this pad to make this electrically connected. And we are done with our positive wire. So now we're going to want to move our negative wire into place. And we're going to do the same thing. And now we have both soldered connections on there. And you can give them just a little test to make sure that they're actually connected, and we're good to go. So at this point, we could do one more quick continuity test if you're unsure. And what this will allow us to do is this will allow us to make sure that we have the circuits completed from our positive on our solar cell all the way to the end of our positive on our RCA sensor. And that'll be nice because it'll let us know that to make sure that we don't have any connections touching inside here. So what we're going to do is we're going to make sure we're back on our continuity setting. We're going to go ahead and touch the positive probe right here, and then we're going to touch the end of our RCA probe where we know the positive is. Let's also touch the shell, and notice no continuity, so that's good. Let's do the same with our negative wire. Touch the shell, and we're good. Let's touch the positive. Perfect. That means we have no shorts. So we've done a good job with the sensor so far. And we have one last piece that we need to do, and that is our resistor. So you're going to take your 10 ohm resistor, and what we're going to do is we're going to use the little solder bubbles that they've already created for us, and we're going to put this resistor right across that solar cell. And I'll explain why in a second and how this helps create the solar cell into an irradiance sensor for us. So I'm going to go ahead and put this resistor in place, and I like to just put a straight line there. Sometimes you can wrap it around to kind of hold it in place. And then we're going to use our helping hands. So there's already a big solder bubble right there, so we may not need too much extra solder, but we're just going to melt this down, just add just a little bit of extra. And we have a resistor touching there. And then let's go ahead and move this one over just a little bit so it's on top of that bubble. And let's solder our resistor in place on this side. And the very last thing we'll do is just another little quick mechanical check to make sure that it's not going to move out of place. That's good. So then what I like to do is we're just going to snip the excess wire off of this resistor. Make sure your safety glasses on. And we have our completed solar irradiance sensor. Now you might ask, we put heat shrink on this side but not this side. And the reason why is because it's very difficult to get heat shrink on here without shading our solar cell. So what we'll end up doing later is we're going to go ahead and add some silicone or even something like hot glue, which we'll do that later once we get these sensors back from you, to cover up the bottoms to make sure that this doesn't corrode at all. And let me go ahead and explain real quickly why we put that resistor into place. So solar cells are great for solar irradiance sensors because they convert sunlight to electricity. And so they end up making something called an IV curve. And what an IV curve is it measures, or it'll tell you how much power the solar cell is producing based on the temperature, the amount of sunlight that's hitting it. And so on our x-axis, we have voltage, and on our y-axis, we have current. And when a solar cell is producing electricity, it's producing both current and voltage. And this is called the maximum power point. And that's where it's producing the most amount of voltage and the most amount of current. And we know that power equals voltage times current. And so this is where we're producing the most amount of power on our solar cell IV curve. You can see right here, or down here, for example, this is where we have the highest voltage. But if you look, there's also no current. And if you look right here, that's where we have the highest amount of current, but there's no voltage. And so these don't produce any power. That's why we want to stay in this region over here to make the most amount of power. The important thing to know for this is when a solar cell is producing power, we know more sunlight will make more power. And the reason why is, let's say this is our IV curve once again, and this side is current. Let's just say this is if you were to stick your solar cell out in the sun right now, and it's going to produce this much current. But let's say we ended up doubling the amount of sun. We would end up getting an IV curve that looks something like this. And so we can see that the current changes directly to the amount of sunlight that is shining on our solar cell. So what we want to do is we want to be able to measure that current, and then we can equate that to the amount of sunlight that is being shined on our cell. And so what we do to force our solar cell to operate around this region is we put a resistor across it. And this is where our 10 ohm resistor comes into play. So when we put a resistor across it, our resistor looks like this. And wherever it intersects with the curve, that's where it's actually going to operate. So it may not produce a lot of power, but it'll tell us roughly how much current is being produced, and then we can equate that to the amount of sunlight that's on our solar cell. So this is our first solar irradiance sensor, and we're going to make two of these with one red RCA and one black RCA. And we'll be able to test these out later and figure out how to equate the amount of sunlight shining on them into the signal that we are getting into our microcontroller. Thank you.